Hi friends and welcome back to another video. Today it is day 82 on hashtag ASR 99 days data science challenge, and today in this video we will look at how logistic regression for multiclass classification works. So in the previous video we looked at what is multiclass classification, a classification problem that has two or more possible outcomes are called the multiclass classification problems, and today we will use the most famous iris dataset and perform the logistic regression algorithm in it. So let's get started. Firstly, let's import the necessary packages. So import pandas as pd and then space, and then import seaborn as SNS, because in seaborn we have the iris dataset as a inbuilt dataset, and then we will import our sklearn.linear model. So sklearn.linear model, and in which I will import the logistic regression, and finally I will import the sklearn model selection and selection, and in that I will import my train test split. Here it is from, not import, so from and from over, and let's run this out, and boom, we have imported them. And now let's load our data. So let me create a variable named df, and in which sns dot I will use the function load data set, and in which I will pass the iris. And now let's look at the first 5 rows of our data. So df dot head, and here they are. We have 5 columns where they are the sepal length, sepal width, petal length, and petal width, and based on that we have the species. So now let's look at how many different species are there on our species column. So for that we will use the unique function. So df of my column species, and in which I will use unique. And here we can see that we have 3 species. They are the setosa, versicolor, and virginica. And now let's change the values. So we know that in our machine it cannot process the text data. In order for the machine to process these data, we must convert them to a numeric value. So let's use the replace function in pandas and change the values for setosa to 1, versicolor to 2, and virginica to 3. So I will store them in the same column. So df of species, which is equal to my df of my column species. It is under the quotes, and then I will use my replace function. And now let's create a new dictionary over here. So let me create a variable yes, and in which I will pass the variable setosa, and I will assign the value 1 for it, and then versicolor, and I will assign the value 2 for it, and my third species, that is the virginica, and I will assign 3 for it, and I will pass the dictionary yes into my replace function. And now let's check for our data frame. So df dot head, and here they are. Now we can see that the species setosa has been changed to 1 now, and now we are good to go, and we can perform the logistic regression algorithm over here. So first let's create the object for it. Let me take a variable named r, and I will create the object. So logistic, and now let's create the variables, that is the independent variables and the dependent variables. So let's take the variable x and df of independent variables. They are these 4 columns: sepal length, sepal width, petal length, and petal width. So I will just drop my column species, and my variable y will contain the column species. Let's run this out. Oops, it is on the axis columns, and yeah, now it is perfect. And now let's split our data using our train test split. So we have to create 4 new variables, that they are the x train, x test, and y train, and our y test, and they will be equal to my train test split function, and in which I will pass my variables x and y, and then my test size would be 0.2. And now it is the time to train our data. So we have to call the fit function, so r.fit, and in which I will pass my x train and y train. Okay, now let's increase the data size here, and yeah, and now we have to predict our desired outcomes. So r.predict, and in which we will pass my variable x test, and here they are. And now let's look at the accuracy rate. So r.score, and in which I will pass the values x test and the variable y test, and here our accuracy comes out to be 0.96. and we can also change the test size, so let's say 0.5, and here we can see that the accuracy rate changes. And also let's check for test size with 0.2, and now it comes out to be the perfect prediction, that is, its accuracy rate is 100%. And we also have another function, that is the predict proba, which helps us to look at the probability for that specific outcome to show up. So let me show you. r.predict proba, and in which we have to pass in the value x test. And here are the probability values. So here we can see that this value is 0.768. As in these 3 values, our probability of the third species is high, and so we got the output as 3. And here in this case we can see that the probability value is 0.98, which is very high, and so the outcome turns out to be 1, that is our species Setosa. And let's look at the last data, and here we can see that the second species, that is our versicolor, turns out to have the probability of 0.82, and so here we got the value 2 here. So our machine chooses the species based on the maximum value. So whose probability is maximum among those all, we will choose that particular species as our output. And yeah, that's all for today in this video. And in this video we looked at the logistic regression for multi-class classification. And thanks for watching. Like the video, leave a comment down below, and let's meet on day 83.